Welcome again, dear students, in this second part of our first lecture. In this part, we are going to study the chemistry of CNS active benzodiazepines and non-benzodiazepine products. Benzodiazepines that are medicinally active as CNS drugs, either anxiolytic, hypnotic, or sedatives. It's very important to understand their structure to activity relationship, their pharmacophoric groups, their planarity and non-coplanarity concepts. We are going to understand the metabolic concerns related to this class of drugs and what is the benefit of using derivatives that are having a step of metabolic substitutions in the market. These derivatives are either formulated as anti-anxiety or to control sleep disorders. Some of them are acting as anesthetics, some others as anticonvulsants, and others as muscle relaxants. Their penetration potential to CNS is definitely different, and this dictates their medicinal use. The dose is always playing an important role in this concern. At the same time, I have to remember you to make you remember that they are having a potential for abuse. The majority of the products in the market are used as anxiolytics. Chronologically, they have replaced barbiturates due to the high or the relatively higher toxicity and side effects of barbiturates. They are having more potential in the market, they are more effective, they are more safer, and again they are acting as regulators or modulators of GABA receptors to mimic the effect of GABA. They are fitting their proper receptor. In this way, GABA is more firmly bound after conformational changes that occur in receptor upon their binding to the receptor. The benzodiazepines active as CNS derivatives are related to the 1,4-benzodiazepine. When we tackle the chemistry of such structures, please have a look on the three different possibly present 1,4-benzodiazepines. We have the 5H14-benzodiazepine, the 3H14-benzodiazepine, the 2H13-dihydro 1,4-benzodiazepine. This green structure, this 2H13-dihydro 1,4-benzodiazepine, is the molecular form that is accepted by the benzodiazepine receptor in brain. Let's consider the prototype of the class benzodiazepines. We are going to take diazepam as the prototype, and of course you know what is the definition of prototype. This is the structure that was heavily studied in different research protocols and where we can apply different structure to activity relationship on it. This is the prototype of all benzodiazepines. Diazepam, as you can see, it is composed or it consists of two rings that are fused, A and B. The ring A is totally aromatic, benzene ring, and the ring B is partially aromatic. It is partially reduced. I can find that the reduction is present at nitrogen number 1, carbon number 2, and 3. For carbon number 4 and 5, it is unsaturated, which maintains a certain planarity of the structure at this point. Ring C is a phenyl ring allocated on position number 5. I can find that on position number 7 I have an electron withdrawing group, which is chloro. The position number 1, the nitrogen, is substituted with a methyl. I can find an active benzodiazepine having no 1 substitution, but of course the presence of a methyl substitution increases the lipophilicity. The chloro, being an electron withdrawing group, can be easily replaced by a nitro or a bromo. Positions 6, 8, and 9 are forbidden to be substituted, otherwise they won't be active, they won't be accepted by the host site on the receptor. Methyl group is optimum for activity, as I told you, but larger group will decrease the ease of fitting on the receptor. The carbonyl function present on position number 2 should be kept as such. It has a dipole effect. It is dipole receptor interactive place. On position number 3, it is not suitable to be substituted unless it is substituted with an OH. Definitely this OH will decrease lipophilicity and it will decrease the duration, and it was found that it is a primary metabolic site where position number 3 is hydroxylated. That's why it's a very important concern when we are considering giving a benzodiazepine for a liver patient or a bordered liver patient or an elder patient. It is better to administer the hydroxylated form, although having shorter duration, although having less activity, but it has less burden on liver when it is dysfunctioning. We can find some derivatives having an esterified carboxylate group on position number 3. It is known to increase lipophilicity, it is known to increase the duration of action, and it should be first metabolized into the active form, because hydrolysis liberates for a second time the carboxylate, and the carboxylated derivative is more active than the ester form. It is of value to think, what if we oxidize or to run an oxidation reaction on this nitrogen? Do you think it will have better blood-brain barrier penetration by increasing the oxygen, or by substitution with the dative bond the oxygen? It's a question to be answered. Because we are going to find some derivatives in this lecture possessing this NO, and we are going to discuss them. The double bond, as I told you, on position number 4 and 5 imparts certain planarity and rendering this part flat, which is accepted by the benzodiazepine receptor. Please pay attention that the phenyl group at position number 5 is non-coplanar with the ring. It should be a planar ring. It should be aromatic in nature. It is not active when it is an alicyclic ring that is non-coplanar. At the same time, ring C should be non-coplanar with, when it is accepted by the receptor, it is fitting the receptor in a non-coplanar way. This ring C is permitted to be a benzene or a 2-pyridyl entity. It might accept ortho, fluoro, or chloro substitution. Position 3 and 4 are non-substituted. Nowadays we can find some diazolo and triazolo benzodiazepine analogues that are more potent, and these diazolo or triazolo are present at the level of the nitrogen and the adjacent carbon. We can find the triazolo and the diazolo function here fused with carbon and nitrogen 1 and 2. Classification of benzodiazepine is related to their therapeutic use. We are not going to classify benzodiazepines according to their duration, rather according to their therapeutic use. I can find some benzodiazepines that are acting anxiolytic, some others that are acting hypnotic, and so on. Similar pharmacological profiles are kept to the same structures, but they have different selectivity and different pharmacokinetic properties. They are all found to interact with the benzodiazepine receptors. The duration of action, the onset is different, certainly with the duration, with the structure. I can find 5 classes of benzodiazepines: anxiolytic, antiepileptic, hypnotic, and anesthetic benzodiazepines. There are other benzodiazepines that might be active as skeletal muscle relaxant and so on. Let's start with anxiolytic benzodiazepines. Anxiolytic benzodiazepines, we can find many of them in the market, starting with diazepam, the prototype of all. Diazepam, as we discussed its structure before, it is the typical prototype of this class. Alprazolam, which is the Xanax, as you all know it, we can trace here the presence of the 5-membered ring, the triazolo ring, on the position 1 and 2, nitrogen and carbon, where it is allocated an extra aromatic heterocyclic triazolo ring. Alprazolam is a well-known candidate of the anxiolytic. Let's apply on them both the structure to activity relationship. We are going to find that position number 3 is unsubstituted. It is safely given for normal patients, but it is of concern when we are tackling liver bordered patient or elder patient. We should consider the hydroxylated form. On positions if this position is 1, 2, 3, 4, 5, then 6, 8, and 9, it is unsubstituted. Position 4, 5 is unsaturated. The 2 rings B and C, there is a free rotation around this single bond, and they are both fitting the receptor in a non-coplanar matter. Ring C itself is a planar ring because it is an aromatic ring. It shouldn't be an alicyclic ring. As a continuation for the anxiolytic benzodiazepines, bromazepam, we have substituted the chloro function with a bromo function. Still, it is an electron withdrawing group. We can find here a non-substituted nitrogen in case of bromazepam. Again, the phenyl group is replaced for a 2-pyridyl function. Coming to the lorazepam, lorazepam is the hydroxylated analog at position number 3, and we can find an ortho substitution as a chloro group on position number 2 of the phenyl function. I can analyze that this OH has imparted certain hydrophilicity that is somehow compensated by the lipophilic potential of the chloro on the second phenyl group. All benzodiazepines are known to be liver metabolized through cytochrome P450 network. That's why, as we discussed before, the cross resistance with barbiturate is present. Diazepam can be N-demethylated, at the level of this nitrogen to yield the Nor-diazepam that is missing the methyl substitution. At the same time, it can be hydroxylated at position number 3 to yield the temazepam. Temazepam and Nor-diazepam, either by N-demethylation or hydroxylation, they will be converted into oxazepam, which is the unmethylated derivative, and at the same time possessing the OH on position number 3. We can trace a second phase metabolism where glucuronidation is happening on the hydroxyl group on position number 3. This diagrammatic scheme that represent the different benzodiazepine metabolites of diazepam is defending the concept how is diazepam, the anxiolytic one, is possessing hypnotic and sedative and skeletal muscle relaxation. This is because it is converted to the oxazepam that, please pay attention, that is more hydrophilic and is acting peripherally as a skeletal muscle relaxant, and it is used to control partially. It is one of the drugs used in alcoholism control and withdrawal symptoms of alcoholism when patients are treated. Temazepam is known to be a hypnotic benzodiazepine. It is used to decrease the number of night awakening. So it has a long duration when considered as a benzodiazepine than one that can be used only to put the patient into sleep. Antiepileptic benzodiazepines, we can consider here the anti-epileptic benzodiazepam, the nitro derivative. It is another electron withdrawing position 7 substituted benzodiazepine derivative. It has nothing on position number 3. It is a non-metabolized derivative. It is having additional chloro on the phenyl ring C. Please consider the duration of action of such derivative as an anti-epileptic agent. Definitely, we can find that its pharmacokinetic behavior and attitude is permitting a long duration to maintain the patient in a safe behavior, so as not to develop seizures outside home or in between doses. Hypnotic benzodiazepines nowadays are known like Flurazepam, triazolam, and here for the second time we can find substitution at the level of the nitrogen. This Dormodore having this substituted tertiary nitrogen function. Please have a look on it. It is not easily de-alkylated. It has long action. It is used to reduce sleep induction time, and at the same time it increases sleep duration That's how patient that is having difficulty in either going into sleep or that is awaking many times a night, it can be used for such patient because it is acting on both concerns. At the same time, triazolam that is possessing a triazole ring at the level of this nitrogen is defending the presence of a fused extra triazole ring. Such derivatives, please pay attention, such derivatives when metabolized, these triazolam and related analogues, when metabolized, they are metabolized on the level of this methyl. They are developing an OH function on this carbon so as to produce an OH, a CH2OH function. This is the way of their metabolism. They are known to have very short half-life. They have a rapid onset. They are only effective for patients that are suffering from difficulty to go into sleep. Anesthetic benzodiazepines, they are used as anesthetic medication prior to surgery. We can find the midazolam, which is known medicinally in the market as Dormicum. It is one of the important anesthetic agents. It is possessing a diazolo function at the level of position 1 and 2, and again the position number 2 of phenyl group is fluorinated like Flurazepam. We discussed minutes ago the behavior or the attitude for being metabolized for such derivatives. Of course, we have to expect that this drug being used as intravenous injection, it should be formulated as water-soluble salt. It is formulated as hydrochloride salt, and it is used as a pre-anesthetic agent like the ones we discussed in barbiturates. Please have the time to read this structure, this slide. The issue of being formulated as hydrochloride salt is important for the administration, but I want you to know that at physiological pH, such derivatives they are interconvertible between the two forms, but the one that is responsible for being absorbed and fitting the benzodiazepine ring is the intact closed ring midazolam form. Other benzodiazepines are meant here to discuss different activity, different medicinal use of benzodiazepines like chlordiazepoxide, that is, as we can see, it is possessing additive bond at the level of the nitrogen on position 4, and the oxygen here is imparting more intensity of hydrophilic properties. It is freely distributed all over the body peripherally, and it is used as a muscle relaxant derivative. We can find some preparations in the market in combination with other derivatives. We can find it with clinidium bromide as the Librax. It is at the same time acting as sedative and skeletal muscle relaxant. Each line that will be expressed in this slide, we have our own defense against it. The structure of benzodiazepine is imparting good lipophilicity, permitting the benzodiazepine to penetrate blood-brain barrier and being easily absorbed from the gastrointestinal tract as lipophilic entities. The structures are all nonpolar, and this is supported by protein binding, and it's proportional. Protein binding of benzodiazepine is proportionally going with the degree of non-polarity of such derivatives. The greater the non-polarity, the greater will be the protein binding properties. As we discussed, there is a chance for the presence of 3-hydroxy group in certain benzodiazepines, and they are better tolerated for elder patients. The derivatives that are free at position number 3, we have understood that this is an appropriate position for the metabolic reactions. There are also metabolic possibilities at the level of the nitrogen by demethylation and dealkylation and further phase 2 conjugation. As we said before, that we can find diazolo and triazolo that are converted by metabolism into the hydroxylated methyl analogues. And the preferred form in border patient is the one that is hydroxylated. That's why we can find it and trace it in the market, and it is advised for such patient to administer the hydroxylated forms rather than the unhydroxylated, although we know well that they have lower degrees of duration of action. Coming to the non-benzodiazepines, they are not new for us. We are going to resume the zolpidem being a non-barbiturate and a non-benzodiazepine analog, and as we discussed before, they are able to act as direct agonist on GABA A receptor. We can add here the alpidem that is used as an anxiolytic. It is not used for its sedative or hypnotic effect. Another type of non-benzodiazepine analog is an anxiolytic well-known drug, dabuspirone, which is dabuspar. It is characterized by each structure having this spirocarbon, where 2 rings are attached together through a spirocarbon. Spirocarbon, yani only one carbon that is a quaternary carbon and is joining 2 rings together. From its name, bu is related to 1, 2, 3, 4 carbons. Spiro is related to this carbon that we discussed now. On is due to the presence of such 2 on function around the nitrogen. This structure is well penetrable inside the blood-brain barrier, inside the brain, because as we can find many hydrophilic groups, but still it is a deca structure. A deca structure, that's to say the 2 rings is composed of are together, the system is composed of 10 atoms, including 9 carbons and 1 nitrogen, and I can find this spacer that is 4 carbon skeleton. At the same time, the piperazine ring. All this is maintaining good lipophilic pattern. It has no addiction potential. It has no tolerance with benzodiazepines and barbiturates. The only issue is that it is subjected to first pass metabolism, which renders its bioavailability low, and it has a delayed onset of action. If we trace its pharmacological effect, it is acting as a serotonin receptor partial agonist. Serotonin receptor partial agonist, يعني it is acting as an agonist antagonist at both serotonergic receptor and dopaminergic receptor. In case of intoxication with benzodiazepine, such a structure, flumazenil, can be used as an antidote for the benzodiazepine overdose. It reverses the activity of benzodiazepine at the GABA A receptor. Such a structure is having an antagonistic effect. It can replace benzodiazepine from its GABA A receptor active site, and we can notice that it is an imidazo. Please segregate the name to understand it. It is an imidazo benzodiazepinone. It is an imidazo benzodiazepinone. This is the structure of the flumazenil, the antidote, the antagonist of benzodiazepine. Thank you, dear students. Till here we have reached our goal. Please read the PDF file I'm sending to you. Hear the recording once, twice, and even thrice, and I'm here to answer your questions. I will try to arrange an active session between me and you in order to receive all your inquiries. Thank you. See you next time.